Yes. Hey, 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 welcome back. Now let's solve the problem. Flattening a linked list. So what is given? You are given a node which can have two pointers now. Not just the next pointer, like the pointer pointing to the next node, but also a pointer pointing to the bottom node. And yeah, that is what your new thing in this, not just a linked list, but a linked list with two pointers. You can, yeah, it is theoretically a tree also because tree has two pointers. What do you call right and left, and right and left have been replaced with next and bottom. So you can call this flattening binary tree also. And if you rotate your head and look at it, this kind of looks like a tree. Like 5 will be the root, and it has 7, 8, and 30 as the left nodes, and 10 as the right node. 10 has two nodes like 20 and 19. 19 has two nodes, 20 and 22 and 8, 28. And 22 can have a left node of 50 and 28. Yeah, this is kind of like a tree only. I don't know. Yeah, yeah, that is a very interesting observation which can be done. And your task is to, yeah, let's look at it properly. Like each sublist is in sorted order. So 5, 7, 8, 30 sorted, 10, 20 sorted, 19, 20 to 50 sorted, and 28, 35, 40, 45 sorted. And your task is to return a linked list in which all the nodes are in sorted order. In other words, you have to flatten it to a single level while maintaining the sorted order. And here is a very weird note over here. I don't know why they have done that. The flattened list will be pointer printed using the bottom pointer, not the next pointer. So it's by chance while at the end, if you do node dot next, then you will get empty values and you will be left wondering where you have went wrong. And let's just look at the example. So you have this what you call linked list, and it has been printed as a sorted order. That's all. So this problem might seem like very hard. You might not understand how to do, but this is very easy to do, and I will show you three ways to do it. One with the time complexity of n times, like the n times m, where n is the number of links, which is number of the right nodes, and m is the number of bottom nodes, and multiply it with the length n plus m. Like the first way also will have n times m times n plus m log n plus m. That is because what we'll do is we'll actually go through all the nodes, just collect the nodes and put them in what you call a link in the array list, sort it, and then create new nodes. And yeah, sorting will obviously take n log n time. So this will take total. So first we'll go through all the nodes, which is n cross m, and then n plus m to n plus m log n plus m to sort the entire nodes. And then other way, what we'll do is that we will use a heap to do the sorting for us. And theoretically, what will happen is that heap will do sorting in log of n plus m, and that's what we hope also. And yeah, but let's do the brute force solution. I get the brute force solution out of the way. So we have current is equal to root, and you'll have answer, which is an I don't know an array. And while current exists, so what you have to do, you just get the current node. It is nothing but cur. And while the cur node dot bottom exists, what you're doing? Yeah, it's bottom only. So what you're doing? First you're getting 5. And while 5 dot next exists, you have to go like 5, 10, 19, and 20 to get those values. And while and for each node, while the current node dot bottom, so 5 after 5, like 7, 8, 30 exists. So you have to do that also. So what you're doing while current node dot bottom exists, curve node dot data, and what you're doing. So yeah, you will do this, and if you do this, you are absolutely wrong. You can't do this. So you can't go next in curve node. You will end up with inconsistencies, and you will just go to 10. But then you'll add the 10, and you'll go to 19. But you're searching for curve node at bottom, so it will just give you a limit of 5, 10, 19, and 20. You don't want to do that. So what you have to do, you have to go to bottom. And after doing everything, what will happen is that you will reach over here. Like your curve node will be here, but your curve is still pointing to 5. So what you can do? Yeah. Now, effectively, what happened is that first you'll go to 5 and till 5 dot bottom is this. So 5, 7, 8, 13 will be printed. And cur node will be here, but cur will still be pointing to 5. And you're doing cur dot next. So you went to 10, and again cur node will be reinitialized to cur, and the process will continue. Let's just have a dummy. Yeah, let's just print our what do you call answer array. uh, Answer, and we'll just return none for now. Yeah. So now what should happen is that you should actually have an array which consists of all the data present in your linked list. So let's just look at it one. So you have 5, 7, 8. Yeah, you should not go till kernel or bottom because you want to actually get the bottom node also. You have to just go till kernel, because if you do kernel dot bottom, so it will come over here and it will check, okay, when it comes to node 30, it will tell, okay, kernel dot bottom doesn't exist. So it will never execute this loop for the last part. So yeah, 5, 7, 8, 30, 10, 20, 19, 22, 50. Yeah, that's what is expected. So now what we'll do? Yeah, this is where the n plus m log n plus m comes. And this is the place where n times m comes. So you have the dummy. You should always use the dummy node. And you have a current pointer pointing to dummy because you don't want to lose the reference to dummy. You should have the reference to dummy also, but you should build on dummy also. So you should have the reference to the dummy. Like in other words, current is the reference to the dummy. And for I in answer, so what you have to do? New node is actually a node with the value of I. And what you will do? Cur dot C. Again, be very careful while going through the question. They are given that the linked list will be printed using the bottom pointer. So what you have to do? Cur dot bottom is actually equal to the new node, and cur is equal to cur dot next. And if you do that, you are again absolutely wrong. You can't do cur dot next. You should do cur dot bottom because you are pointing, like you are printing the bottom nodes. And at the end, you can directly return. You are actually returning the dummy. And if you do this, you are again absolutely wrong. You should not return dummy because dummy is the dummy node. You should always return dummy dot bottom. And yeah, so just comment and try to run it once. And expected and actual maps. So on submission, what will happen is that, yeah, it worked. And the time complexity of this is n times m multiplied by n plus m log n plus m. And obviously that is not good. You should never have n plus m, like you can actually increase it also. Like I mean that you can decrease the time complexity. You don't want to increase it. So what we'll do is that we'll use heap over here. So heap is actually directly present outside, and we'll have this will actually be a heap now. So what you will do, for answer, you can't append into heap now. So what you will do, into the heap, you want to append the kernel. You want to append the data of the kernel. And yeah, again, everything the same. And so no, there's no need to solve it. So your n type, n plus m log n plus m goes. And you can't do for I an answer now. So while the heap exists, so what you have to do, pop out the current node from the heap. I mean the data from the heap. You have to pop out the data from the heap and create a node. Let's just create a node over here. And what you'll do, cur dot, you'll do the same thing. Bottom is actually equal to data, and in the end, what you'll return? You'll return, yeah. So your time complexity went from n. Let's just verify it works once. Yeah, let's just submit it. So your time complexity went from n plus m, n times m, multiplied by n plus m log n plus m to n times m log of n times m, log of n plus m. So yeah, this is a way to do. This is another way to do it. And what you can do is, yeah, there is actually another way to do it using heap only. Like majority of the code will be same, but you have to do some minor modifications. So what you will do is that while cur exists, we will not push the bottom node. Like we will not push the bottom node to the heap. Like for while car exists, we will not go through and push 5, 7, 8, 30 to the heap. So what we will do, we will into the heap, we will directly push uh, into the heap. heap q dot into the heap. You will directly push the current node itself. You will push the current node. But the issue is you can't push the current node like this because like the heap works on comparing the values while shifting up or down. So you have to actually pass the reference also. Like you have to pass the date also so that the sorting can be done. Yeah. And cur is equal to cur dot next. So what you will do now? You will have an answer variable and answer can't be a variable. Answer should be a node with the value none, and you will have a pointer pointing to it also. And while heap exists, you are getting the current node from the heap, and you have the date also. Cur node is equal to from heap. So you pop the current data and current node from the heap, and create a new node from the data, and cur dot bottom is actually equal to new node, and your work is not done now. Yeah, you should do cur is equal to cur dot bottom, and your work is actually not done now. So what you have to do, if the cur node dot bottom also exists, so what you have to do, into the heap q, it's not heap, into the heap, you want to push the cur node dot bottom also, and then you can return answer dot bottom. So let's just verify this also works. Uh, yeah, you can't directly push cur node dot bottom, you have to pass the data also. Yeah, this also works. And when you submit it, this should also theoretically work. So for node dot bottom dot data, and why is it telling that we can't compare nodes? Did it not run when I did this? Very interesting. So when I submit it, it tells line 34. Mm, Curve is equal to curve dot bottom. Curve dot bottom is new node. Mm, Where is the error coming? So it's telling the error is coming from line 31. That is telling in line 34. What is this inconsistency? I can't understand why heap exists. For node dot bottom dot data, and you're appending the for node dot bottom only. Mm, this should not actually happen. I don't know why it's happening because the same comparison is being done over here and it's working. But when it comes to this part, still it's not working. Only if the kernel dot bottom exists, only then you're pushing it into the heap. If you dot push into the heap, you're pushing kernel dot bottom dot data and the kernel, and data will always verify that the bottom will always be the comparison part will always be what do you call this one. The heap, and then current dot bottom. Will this work? This should not work. Let's just try it out. Let's submit it once. Yeah, whatever to do. Comparison over here works, but comparison over here is not working, and I honestly have no idea why it's not working because both the comparisons are complete the same itself. Is it? Yeah, I don't know why it wanted me to tell kernel. Okay, no, still I have no idea because even before it is not giving compile time, it is giving error over here. So yeah, again this makes no sense. This error should not come. Let's try to ask Yogi bot. Yeah, I'm actually not pushing the node class. I'm pushing for node dot bottom dot data itself. And I'm not actually pushing the entire kernel. Yeah, this should not happen. I don't know why it's happening. So what we can do is we can actually define a custom comparator for like it will again we'll have the same thing. And it is this LT and we'll pass the node for it, node over here. Node to return this less this dot data is less than node dot data and the EQ we have to pass self for it and not this is self. Mm, so what we can do is so now we can actually directly push our current data, but we can't directly push the current data. We have to modify it to our custom node. So this also can be removed now because we're actually giving our custom node over here. Mm, will this work? 138. Okay, again, the error is coming from here because you're not giving two nodes. We'll just compile and run those. We'll get an error over here. So we have to remove that also. Yeah, at least 510 1928. So the values of 510 1928 are 510 1928 and Piper exists. Directly push creating a custom node. Next is also yes, and I think I figured it out. So what we have to do is we are wrapping our custom node like this, but we can't just wrap just pass the custom node. So what will happen is that when I compile and run over here, so what should happen is that we will just get the values of these values over here. Yeah, 5, 10, 19, and 28. And there is not one mainly because when we wrap this in our custom node, so what is happening is that our next and bottom pointers are not being populated. So what you have to do, you have to have the value of next and bottom also. So you'll have the value of curve.next. So now what is happening is that you are actually passing the entire node as a custom node, and everything else will remain the same over here. And new node curve.next will actually be our new node. But while pushing into a heap also, what we have to do, we have to wrap it in our custom node part, and the same thing should be done over it. So we are passing the current node bottom, and bottom dot next also should be passed, and bottom dot bottom also should be passed. Now let's compile and run, and you should have command none. Now compile and run, and next dot bottom. You have to pass your custom node here, so you can pass our new this node over here. So node dot bottom, node dot bottom and next, and wrapping is done properly. We're getting 5, 10, 19, and 28. Which is 5, 10, 19, and 28. We're returning answer dot bottom node, current node. We're copying the current node. Current node dot bottom is equal to current node. If current node dot bottom exists, so what you're doing? Now let's ask UGBot again and see what it is. And free trial has ended. Mm, If the current node of bottom exists, we're pushing the leaf, the custom node of current node bottom. The data current dot next. Why is it still telling like this? Let's get print out and check it out. Okay, everything is done over here. So that means that there is something wrong over here. And that is because they're not reassigned it. What am I doing? Yeah. Now this should theoretically work. And now let's compile and run. What is this error? It's telling self.data and node.data. So we have to pass node.bottom.data over here. We can't directly pass the node. And yeah, it works finally. My God. Oh my God. Yeah, this was for it. Two ways worked flawlessly, but the third way was torture to do. I don't know why. I don't know why the first of all, why the actual way did not work, and I had to create a new custom node and have custom comparative functions also. And yeah, but that's all for it. And thank you for watching, and see you.